These are the solutions to the Unit 2.1 pop quiz that you had in class. You need to utilize your paper that was handed back. Watch this video, walk through the solutions, actually do the problems again, and prepare yourself for an additional test that will be coming up over Unit 2.1. You will have test questions very similar to the ones that were present in the pop quiz. Please make sure that you are practicing these questions. For the centroid problem, all you had to do was utilize the formula for a square, just base, half of the base and half of the height. So in this step, the base is 0.75 over 2, and that actually is going to give you your x value of 0.375 inches. Your height was a half of an inch over 2, and that's going to give you a y value of 0.25 inches. The triangle is a little bit different. The formula is a third base and a third height. So plugging in the value for base, 1/2 inch divided by 3 is going to give you an x value of 0.167 inches. Y value is 1 inch over 3, so the y is going to give you 0.333 repeating. You were also asked to label, so you would need to draw the centroid locations in here. For a moment of inertia, in this case, the dimensions are given here. We're using 3x6. You do not need to reduce this. This problem is not asking you if this is called a 3x6. It is giving you the exact dimension. So there was some confusion on that. In this situation, we're just going to utilize the actual numbers up here. So just the 3 and just the 6. So it's a little bit different than the actual value of the wood that we were using. This is assuming this member is not made out of wood. It does not tell you that it's wood, so you have to just go with these values up here. So in this situation, my moment of inertia for my vertical orientation is going to be equal to my base times height cubed. So because it's standing up vertically, my base in this situation is 3. My height cubed is 6. You divide that by 12, and the moment of inertia is going to be equal to 54. And moment of inertia is expressed in inches to the 4th. For the horizontal orientation, my base is 6 and my height is 3. Cube that over 12. Moment of inertia is 13.5 inches to the 4th. Make sure that you are only cubing the height. When you punch this into your calculator, Do not cube everything on the top. It's just the height. Free body diagrams, you're being asked to draw a free body diagram of both the statue and the base. You can draw a very simple shape for both. Let's just call this the statue. The statue has some weight that is pushing down. So that is the weight of the statue. This includes gravity. A lot of people were trying to add gravity on there. The object is not going to have any weight if it doesn't have gravity added into it. So that's why we just use the weight of the statue. And then we also have the force of the base pushing back on top, or to the bottom of the statue. The base, again, very simple object. You can just draw a shape. You are labeling the base. Standing on top of the base is the statue. So that's the weight of the statue here. But you also have to add the weight of the base here. And all of that is counteracted by the force of the ground pushing back up. Calculate the magnitude and resultant force of A. You had to do two things in this. The first thing was find the force vector A. All that is finding the third length of the triangle. So if you have two lengths of the triangle given, you can use a Pythagorean theorem. So A squared plus B squared equals C squared. You plug in your values. You can just use 114 for A, 73 for B, and that's going to equal your C squared. These two numbers are going to give you a value of 18,325, and that equals C squared still. So the square root of 18,325 is going to equal right around 135. So my answer for A is 135 pounds. The next thing it asks us to do is find the angle. So this angle theta down here, you need to use SOHCAHTOA to figure out this angle. So if you have the opposite line and the adjacent line, utilizing SOHCAHTOA, you're going to have to utilize tangent. So the tangent of the angle is equal to 114 over 73. So in order to find theta by itself, you would need to take the inverse tangent of 114 divided by 73, your angle should be 57.36 degrees. Static determinacy. You were asked to figure out if this truss was statically determinate or not. To do that, you're going to have to utilize the 2j equals n plus r. The 2 is a standard. J is coming from your number of joints. So here's 1, 2, 3, 4 joints. And that is equal to the number of members. So there's 1, 2, 3, 4, 5 members, plus your number of reactions. Your reactions come from your connectors. These are pinned. These are not rollers. Remember, if it is a pin connector, that means it has 2 reactions. So it can have a reaction force 2 ways. So if this gives you a value of 2 here, and this gives you a value of 2, your number of reactions is 4. So 2 times 4 is 8. 5 plus 4 is 9, and we know that 8 does not equal 9. So this truss is not statically determinate. It would be called statically indeterminate. Question number 7. You were asked to find the reaction force at point C in the y direction. In order to do that, you needed to find the moment based upon A and utilizing distances. You have to look at these forces here. So first and foremost, you can say I have 1,100 pounds plus 600 pounds plus 350 pounds. Values in here. So I know the overall force of this truss system pushing downward is 2,050 pounds. You cannot just divide the 2,050 pounds equally between point A and point C. You're going to have to find point C before you can find point A. So what you have to do is use the equations. Moment equals force times distance. And in this case, for point D, your moment is 1,100 pounds multiplied by the distance of 3. 3 comes from here. You're starting at point A and you're finding your distance over. That's going to equal 3,300. The next step, here at point B, same thing, moment equals force times your distance. So my moment is 350 pounds multiplied by my distance, In this case, my distance from point A to here is going to equal 5. I got the 5 from this 3 plus half of the 4. So 3 plus 2 is 5. So in this case, my moment is 1750. Next part here is E. Same thing, moment equation, force times distance. In this case, my force is 600 pounds multiplied by my distance of 10. Or 7, excuse me. The distance is 7. I get the 7 from this 4 and this 3. So the overall distance from point A to point E is 7. I jumped ahead a step. So your moment is equal to 600 times 7, and your moment is going to equal 4,200. You're being asked to find the reaction force at C, and it's the same situation. You're going to find your moment is equal to your force multiplied by your distance. Now the distance is where my 10 comes in, so I jumped ahead a step last time. So 3 and 4 and 3, 3, 4, 3. You add those all up, that equals 10. So in this case, we do not know the force yet, but we do know the distance. Now if you remember, all of these forces need to add up and cancel each other out and equal 0. So over here on the side, the last piece of free space I have on this page, I'm going to add my 3,300 plus my 1,750 plus my 4,200 . And that will give me a value of 9,250 pounds. And that force is pressing down, so that's actually going to be a negative number. But in this case, you need to understand that this is all going to add up to 9,250. So 9250 here is my moment. I'm trying to find my force, and that's multiplied by 10. So all I have to do is get F by itself, divide by 10. So my final answer, my reaction force at point C in the Y direction is 925 pounds. That was the answer we were looking for. Using that information, you can then come back over here. If you have 2,050 pounds pushing down, you know you have 2,050 pounds pushing up. So 2,050 minus your 925 you will have 1,125 pounds here at A. So 1,125 pounds here, 925 pounds here. All the question was asking you though was to find this answer. So all that information, all those steps were leading up to this answer.